Okay, now we are.
Perfect. Thanks. All right. Good morning, everybody. Oh, let me just turn off the lights here in the room so you guys can see better. Okay. All right. Good morning, everybody. Excited that today I think is the actual day that we're gonna play with some data. So I'm excited for that and to be showing you guys, walking through some of those steps. So the first thing I want to ask you to do, and again, so in case I haven't been clear, all my content is basically going to be live coding, right? So yeah, so to get us started on the right track here and make sure everybody can follow along, I just want to ask you. I'm showing you here on the screen my overall folder for the course, as we talked about last Wednesday. And if everything went well and successfully, you probably have, so just to remind you, so the 2022 Advanced PA is the one that is linked to GitHub. So again, this is the one that you'll be getting materials from me, but I don't recommend that you save your things in it. So see that more as like a cloud folder that you're going to be getting things from me. Then we talked about creating your personal folder where we have the project, which is the one that I asked you to include your initials at the end of it. So I think everybody was able to do that successfully last time. So I just want to invite you to go inside of your own folder with your initials. And if everything worked right, you should be seeing something pretty much very similar to what I have here. So you have three subfolders: the code, data, and output. And now maybe we didn't really have a moment to stop and show this, but now you have that .rproj icon in that folder. So this is the icon that if you double click on it, is going to take you to the project that we created. So please go ahead and do that. Double click on that rproj, and then that's going to prompt. Let me just minimize the videos here so I can see. That's going to prompt an RStudio session. And if you had your partial script already open, it's going to pop up right there. If you come here on the side on the files and you click on that R blue button, it's going to take you to the root directory of this project. So not on your computer root directory anymore, but it's focused on this project. And again, this is one of the benefits of using projects. And if you are not seeing your script here, you can just browse on the files tab. You can just go inside code and it should be here. And if you click on it, it will pop up this R Markdown script. It's going to pop up on the left. I just want to take 5 seconds here just to ask, and if you were not able to do this, please let me know, because you're not going to be able to follow along if you were not able to get to this point. So if anyone has had any issues opening the project and the script, please speak up. Okay, I don't hear anything, so I'm assuming everybody was able to do it. So we're going to move on here. Okay, so today, we're finally going to actually start working with EOMonitor data. And we kind of stopped. So last time we spoke about what is this file that we're seeing in front of us. This is an R Markdown file. What are the benefits of using R Markdown compared to just an R script, which is basically that in the R Markdown file, we have chunks, which are these different colors that start and end with apostrophes. They are useful because they kind of work like the console. And if they produce output, the output's going to be right below them. So you have this intermingle between code, output, and your own comments. So if you write outside of the chunk, you can just write normally. You don't have to have the hashtag. You can just write normally, and that's not going to be interpreted by R. And with R Markdown files, R only interprets what's inside the chunks. So we basically went through this first chunk here, which is the setup. Normally in all my R scripts, if I already know what package I'm using, what I'm going to be doing in that script, I usually like to combine all the library functions to load the packages that I need on that script right on the first chunk. So I see right away what I need. Sometimes, as you're becoming more familiar, it happens with me a lot that I'm developing my script and I remember, oh, I need that extra package that I didn't think about in the beginning. It's no big deal. I just come here, write again, like library, and then I just add that package up here. It doesn't really matter where you add that library function. It's just that I think that having on top, it's useful for organizational purposes. Okay, so also something here that the chunks do is if you want to run a chunk entirely, you can just go ahead and click that play button. You're going to see this progress bar on the side. And when that's gone, it means basically it was run. If there was any error in the code, it's going to appear right below the chunk. Also, a trick here that I want to teach you is, so right now let's say that for some reason, let's say I remember, oh, I remember a different package. You don't have to do this here, but I just want to show you. I remember a different package that I'm going to use that's called car, for example. It's not the case, so you don't have to do this, but I just want to show you. And now, I mean, I could just hit the play button. That would be easy enough, but I really only need to run this line of code here. The shortcut I normally use that's going to be super useful for you as you work with R is so on a Mac is command return. So like command enter. If you're on a PC, I think it would be control enter. If you do that, if you just place your cursor in a given line and you just hit command return, it's gonna run just that line of code or any other lines of codes that are connected to this. We haven't seen that connection yet. So for now, let's just forget about that part of it. But if you just place your cursor, command return runs only that line of code instead of the whole chunk. Okay. So what we're going to do, I'm just, if you already have this typed and working, great. I'm just going to delete here just to show you again. So the goal here is to import the yield data set and save that temporarily on this object called yield17. So to do that, and if you haven't done this yet, you can start coding with me. You just use that assignment symbol. And then if you were able to load successfully these packages, there's a function inside the readr package that is called read_CSV. And as you type, is going to already prompt you to that. And then once your cursor is inside the parentheses, you open and close quotation marks and you hit tab. If you do that right there, it's probably going to autocomplete all this name for you because the script that we're using is inside of the code folder. And right now it's the only script there. So it's kind of auto-completing already. What we want to do is get outside of the code folder. So I'm just going to show you visually here. So we're right now inside the code folder. I want to get outside of it on the main directory of the project, go inside the data folder and read the yield CSV. So to get outside, you type .. /. So that takes us outside of the code folder. And if you hit tab, it's showing you what's at the main level of the project. So you can just select data folder, hit tab again, and it's going to give you two options there. We're going to import the KB2 EO 2017.csv file. So if you do that, and if you can just go ahead and run the entire chunk, which is going to read this file and print the data set right below it. Okay. So this is key. We have to have this data set imported to be able to use it. So if you were not able to import it like I showed above, please speak up now. Okay, I don't hear anything, so I'm gonna move on. Oh yeah. Were you able to run this chunk here?
Yes, I'm just trying to set the time.
Okay, perfect. Because yeah, we can check the SF. If it's not working, we can check in a moment here because we're not going to use right away.
Okay.
So I guess we can just keep going. Then whenever we get to the point, I can help you out. Awesome. Okay. Anyone else had any issues? All right. I'm gonna just decrease my font size here so we can see better. Okay, so we printed this data set right below here. And as I was telling you, if you click, it has 31,000 rows and 18 columns. You can use those arrows right there to browse the columns, and you can use these numbers down here to browse the rows if you want. What I want to do next, and I'm not going to spend too much time at this point right here, because I want to explore this data set using some of the functions that we've seen already. So please go ahead and go to the next chunk here that we're using the class function. You can just run that chunk. And here I'm just really checking what is the class of this object, right? Because it is a yield monitor data. It is geospatial data. But at this point, the main point here is to show you that it already seen as a data frame, and none of these other names here represent spatial data, meaning that even though this is spatial data, R does not know that yet. Okay. So next, let's come to the chunk below it, and let's use the function summary on our object yield 17 and run that. So as we saw, last class with that simplified data set, the function summary is going to look at your column, see how R interpreted it, and it's going to give you some summarized information about it. So for example, we have FID, which goes from 0 to 31,000. It's basically just an ID for each data row in this data set. We have region, heading is just the angle. So it goes from, in this case, 105 to almost 360 degrees. Elevation, I think, is in feet. We have distance, which is the distance from one point to the next as the yield combine is recording yield data. Duration, speed, fuel, moisture, mass cotton, width of the header width. If it's engaged or not, we only have -1 for all levels of this column. We have mass yield, wet yield. You can see the minimum, maximum ranges there. And one that I want to call your attention, because I mean, there's lots of columns here. They don't really have units, so you don't know for the most part. I mean, you may have some idea of what they are, but you don't know what they mean exactly. So I just want to tell you that the dry yield here is the one that we're going to be using, and this is in pounds per acre of lint. And then we've got a timestamp, and look here. So we have two columns. One is called point X, another one is called point Y. These are the two columns that have the spatial coordinates for this data set. However, as we said already, R doesn't know that those are spatial coordinates. It just sees as numbers right now. So he hasn't fully understood that. And we're going to
Leo, let me interrupt just a minute to explain the difference between mass yield, wet yield, and dry yield.
Yes.
So you may remember when last period when I was showing you how these data were collected with a John Deere yield monitor. The microwave sensor that is used for this actually emits microwaves at different wavelengths, and it's able to discriminate between the response of moisture and the response theoretically of seed and of lint that's coming through those ducts up into the basket. So that's how we're able to calculate how much moisture is in the sample that's coming by and extract a dry yield for it, right? So there's no magic happening. It's the sensor that's collecting those data.
Perfect. Thank you, George. So I'm just going to bring this up here, and I just want to ask you all here, what columns do you think are really, because I mean, there's lots of columns here, and for our exercise, we're going to use only a handful of them. And maybe you don't have to give me the full complete list of what we're going to be using next, because you don't know what I'm thinking. But just looking at these columns here, can you at least think of like, well, this one for sure we're going to need, and maybe others, but these few here, for sure, we're gonna need if we want to do geospatial yield data cleaning with this data set.
So the point X and point Y, that's the coordinates.
Yes, so Spen just mentioned point X and point Y. That's definitely true. We're gonna definitely need those columns. What else do you guys think that is gonna be really needed? Any guesses?
Obviously yield. I
Yield, yeah. That's definitely gonna be needed here.
guess that
So-
doesn't need to be said, but you know, it's the easy one.
Yeah, so at least one of the yield columns, and I can tell you that we're gonna use the dry yield column moving forward, but yes. So yeah, the very bare minimum for sure, X, Y, and yield. Awesome. Okay, so one thing, as I was telling you here, so dry yield is in pounds of lint per acre. And remember that we mentioned that using the summary function can be helpful to spot something wrong with your data. So if we just look at this quick statistical summary here, we see that it ranges from 0. I mean, it is possible to get a 0 yield, right? If the minimum was a negative number, definitely red flag, right? Definitely that cannot happen. But then as we move here and if we look at the maximum, so 10,000 or almost 11,000 pounds of lint per acre. I am no cotton expert, but I don't think that's really realistic, right? So this would be a red flag for us, knowing that, okay, this data set here definitely need at least some massaging to make it more realistic. All right, so this is just like a numerical summary, right? I am a huge fan of plots for exploring data, for showing data, showing results. So I want to ask you to come to the next chunk here, and we are going to do, we're going to use ggplot to do some plotting and explore this data. So the first one that I want to explore here is just the distribution of EO data. So not a spatial distribution, not geographic distribution, but just the data distribution itself. Are you guys familiar with like histograms? Have you seen that in any stats courses? Okay, so that's kind of what we're doing here. And I just want to invite you to start typing with me. So if you recall, to begin a ggplot, we just start saying ggplot at the top level. And then let me just make sure I'm following my cheat sheet here. And so the first argument that we give ggplot is a data frame or the object name. In this case, it's yield 17. And then we add a comma. And the next argument here is we give that AES function, the aesthetics function, where we define what goes on X, what goes on Y. In this case here, we're going to do X equals, and then we're going to just copy this name here, dry yield. You can just, I mean, if you just want to type it out, you can. I just copied because it was right there. And we're not going to define a Y, just X. X equals dry yield. And remember that R is case sensitive, so we have to have those upper D and Y, uppercase. Okay, if we just run this, again, it shows that canvas for us, but nothing is in the plot yet. We have to ask ggplot for a geometry. To do that, we add a plus at the end, hit tab, and then we can start typing geom underscore. Again, there's a whole list of them, but the one I'm looking for is density. So geom underscore density. If you run that, this is what you should see. So geom density is really, is really just, imagine that you have a histogram and that the density is really just like the outline of that histogram. It's just giving you that idea. I'm going to show you here just quickly the histogram so you can see, but you don't really have to do this because we're not going to use histograms. So this is what the histogram looks like. And the density kind of just draws on it. I personally prefer to use density than histogram because I feel like histogram has some subjectivity to like how many bins you have, what's the size of the bins and all that. And density kind of takes that subjectivity away and really shows you the shape. Okay, so looking at the distribution of the yield data, again, not spatial distribution, data distribution. Starting at 0, we see there's a good number of points right here is 0. There is a peak around 3,000, which is, I guess, pretty realistic. But then we have this long tail here because we probably have 1 or 2 outliers that are really bringing the tail of the distribution all the way past 9,000 pounds of land per acre. So again, visually, now we're seeing what we had already interpreted just from the numerical summary. Okay, cool. So now what I ask you to do is just copy this code that we wrote. So just copy that and paste on the chunk below. And now we're just gonna change the X. Instead of being dry yield, it's gonna be speed. And it's just upper S speed like that. So I wanna explore the speed component of this, or the speed variable. So if we see here, if you're able to change, copy and paste and change the variable, you can see how most of the points, so this is the speed of the combine harvester, right? So we see that most of the points are here between 4.5 and 5 miles per hour, which is pretty reasonable. But we have some points that are very low, like 1 mile per hour. We know that this is probably, I mean, it's probably true. I'm not saying it's not true. It's probably true. But we know, I mean, maybe you guys don't know actually, but one of the main, because I haven't read, maybe if you read the paper already, you may know this. And if you haven't, you will learn after you read that one of the main causes for EO data monitor errors is because of quick changes in speed, or when the speed is too low of a speed as the harvester is moving. So possibly the EO data points that were generated when the speeds were really low could be erroneous. And we're going to use this information later to filter out these EO points that were collected under very low speeds.
Let's explore why that might be the case, Leo, just a second. So in this particular field, you remember from the photographs I've showed you from Google Earth, there were a lot of areas with a lot of erosion, right? There were, obviously, when you go to the field, there's some areas that are knee deep as gullies. And so what happens is if you're harvesting the field, or you're doing any kind of field activity with a vehicle there, when you approach that gully, you have to reduce speed. Otherwise, you're going to pull off an axle, right? Or break your machine. And so what happens with the yield monitor is that you slow down dramatically. So they hit the brakes to slow down. And there's a surge of cotton that's still in the machine that's moving through the machine up through the ducts. And now the GPS that's tagging the coordinates there, is tagging coordinates very, over short distances. And so the yield is attributed to a smaller area than from which it was collected. And that's why speed is such an important factor when we're looking at cleaning up yield data, because when the machine is accelerating or decelerating, you're confounding the area over which the yield was collected and attributing it. Because the yield data we show here is mass per unit area, pounds per acre, right? It's not just raw pounds, it's pounds per acre. So we could really dive back if we wanted to really clean this up and say, okay, how many pounds were collected in this minute over what area, and recalculate the yield, and maybe then we could use a lot more of these points. But really, it's much simpler to do what we're going to do now. Does everybody understand what I'm describing? Okay.
If you guys here in the room have any questions about that?
The same thing happens when you get past the gully, right? Because then your machine has still been running. There's no cotton in it because you're going across a gully. And then the operator starts accelerating to get up to speed. And so you've got cotton coming in, but you're moving much faster than normal. So the yield is going to be abnormally, it's going to record incorrectly low versus incorrectly high when you're slowing down. Okay, all right.
Perfect. Thank you, George. That was really, really helpful. And also something that I would just want to make a distinction here. So when we were looking at the yield density up here, so yield is being estimated, right? Based on speed, on area, on how much mass is being harvested going through the sensor. So yield is estimated, and there could be yield data that is erroneous, like, oh, this is too low, this is too high. We have to remove the yield data itself. On the case of speed, It's not that we think that speed was measured incorrectly. The speed is probably measured correctly into a good precision here. The thing is that we know that when speeds are too low or too high, that can have a direct impact on erroneous yield estimates. So that's kind of like, on the yield, you're actually seeing this yield is wrong. On the speed, you're not saying this speed is wrong. You're saying this speed is causing potentially erroneous yield data. So it's kind of a distinction between these variables. Okay, so let's do a quick map here just to take a look at the distribution of yield in this in this data set. So let's start. So come down to the next chunk. Let's start with the ggplot call. Let me increase my font size again so you guys can see better. Okay. So ggplot, again, the first argument is the data set name. So that's yield 17. You add a comma, hit space, and then we're going to add the aesthetics of this plot. So AES, open and close parentheses. The first thing that I want to add here is the X. So this is kind of interesting because now we're going to make a map, and to make a map, we have to have X and Y coordinates. So the X here is actually going to be the point X column that we had in the data set. So that was, it was all uppercase point_X. Now, after that, I want to ask you to add a comma and hit tab. So this tab here, again, is just to make it easier for us to see the code. It's not like, if you didn't hit tab, it wouldn't work. It's not like that. It's just to break the code a little to fit better. So then we say y equals point_y. And if we just run at this point here, what we see is basically the coordinates that we had on the y and on the x, but still nothing showing on the map yet, because again, we haven't asked for any geometry to be added. So I'm just gonna come back up here on the code, add a plus after that last parentheses, and hit enter again just to break the code. And we can add, well, I was gonna ask you guys, but maybe we can just go ahead and do it. We're gonna add a geom point here. And if you just run it, so add a geom point, I just ran it. And this is what it looks like. It's not very helpful, right? I mean, we're just seeing 31,000 points with a black shade, which is not really telling us much. So if we wanted to give color to these points, but not just like change, not just make all of them red, but if I wanted to give color that would change based on the yield data. Can anybody just help me here to think about how we would do that based on what we did last time?
I think we definitely want like a red to green or green to red scale. I'm trying to remember what we did Wednesday in class, but somehow do that, just a gradient of, green to red, for green for high yield, red for low yield, that kind of thing.
I like where we're going, and that's definitely what we're going to do. Thanks, Emily. And I'm just going to help you guys here on the immediate next step here, which is how do we tell ggplot that we want the yield to affect how the color changes here. So we
I'd like
use
to point out before we go much further that 13% of males are red-green colorblind. So be careful with your choices of color, including me, by the way.
It's a great reminder, and I can imagine that these plots are tough for colorblind people to really differentiate. Yeah, and well, okay, I'm going to make a very quick tangent here just to mention, George, that in ggplot, we're going to play with colors and choices of colors and all that more later, but there is a color palette that is colorblind safe that you can specify. So they do have some inclusive options like that I think is really cool, and I actually try to use most that I can when I'm doing papers and things. So there is that option. I think is really cool. Okay, so coming back here to what we were talking about. If you guys remember, if I want to change just the color overall, I can just say color equals and then a color name and run it. I mean, yeah, not very helpful, right? It just changed the color, but still all the same for all the points. If I want to change color based on a variable, on yield, I have to do that inside the AES function, the aesthetics function, and I have to say color equals and then variable name in that data set. So the variable that we want to use is dry underscore yield with D and Y uppercase. Now, if we run this, this is what happens. ggplot sees that dry yield is a numerical continuous variable. And because of that, it assigns a gradient. And this is the default gradient that ggplot uses. So going from, a dark to a light blue. It kind of does a trick. We can kind of see some of those gullies and, some so dark here is low yield, so lower yields on the end rows. So we do see some features, but as Emily mentioned, normally, and perhaps that should change, normally the color palette that is used for yield data is red to green. So if we can change that here, and I want to show you how we can do that. So to change that type of gradient, or what are the colors controlling the gradient, we're going to come here at a plus to the end, hit enter, and then you can start typing scale underscore color underscore gradient. And as you start typing gradient, it's good. You can just select the first one. And then inside here, we can kind of see already on my screen, it has a low and a high argument there. So what we can do very quickly here is just to say low equals quotation marks red, add a comma, and say high equals quotation marks green. So if we do that, let me just go back and show you my code and run it. Now we see that the lower and upper color limits have changed from 0 being red and green being high, or sorry, for red being low and green being high. And right now, I just want to call your attention to one feature here of this map. We see that there is one point that is very, very, very green. That's the highest point that we know it's probably unrealistic. And because that point is pulling the color scale all the way up, it kind of masks everything else as almost red, right? And because we know that that this data point here is probably not realistic, so just for visual assessment, we're not filtering the data yet, but just for visual assessment, I just want to restrict the range of yield that we show in the plot. So I want to ask you to copy this code here and paste. Oh, actually, never mind. It's already there. I forgot that I left it for you. So you don't even have to do that. So what we're doing here is on that first argument of the ggplot, I'm using this function called filter, where I give the data set and I give a condition on one of the variables of that data set. So I'm saying for this data set here, look at the dry yield column and only gives me the values where yield is below 5,000 pounds per acre. So I'm gonna just only running this part of the code here and show you what that does. So just that part returns a data frame as well, the same data frame as before, however, now with that filter applied. So that's what's doing. We're doing a filter on the go. We're not saving this filter result yet to our data set. It's just like on the go, just so we can see the results. So if you just run this chunk here that we only kept the yield data points below 5,000 pounds per acre, now we can really see more of the distinctions of how yield varies spatially in this field as compared to above, where it was pretty much everything kind of red and then that very bright green point alone there. So here we can really see some of those features. If you guys recall, George was saying that these red streaks going across are gullies, like eroded parts of the field. And so we can really see, and that makes sense, right? Okay.
I'm scrolling up just a little bit so we can see the code, because I was trying to retype it just to learn it, and yeah,
You
just
see it up here?
right there. Yeah, thank you.
Yeah, absolutely. And it's great that George asked that, and I want to tell you guys, sometimes I'm coding too fast, I'm moving too fast, maybe, and I try to remind myself to leave the code up here so you can see what was done. If I'm going too fast and you just need a quick refresh of what I typed above, please let me know. I really want you to follow along, and sometimes I forget to keep the code up there for enough time.
Here's a question, Leo. If you could scroll up to when you showed us the density plots of yield, the first density plot you made.
Mhm.
Is there a way? I'm sure there's a way. What's the way of actually showing the individual data points on this graph so we could see how many we have as outliers?
Yes, so directly on the density plot, I don't think there is a good way, or maybe there is. I think there is a geom rug. Let me just try that very quickly. Maybe geom rug adds the, yeah. So geom rug here, what it does, let me just show you again the code. It basically adds like a vertical line on this bottom part here for each data point that we're seeing. And of course, because here there are like 30,000 data points, it's kind of crowded. So maybe this would not be the best option to really show this data. Yeah, but that's one option. Another option
shows exactly what we want to see. There's 1, 2, 3, 4, 5, 6 data points that are dragging that tail out there, right?
Yep, absolutely.
Or there could be more that are on top of each other, but relatively few anyway.
Yep.
So your choice of 5 wasn't really bad, of limiting it at 5,000 was, I mean, we've lost a few, but not a whole lot.
Yeah, that's true. I had not looked at this when I decided 5,000. It was pretty arbitrary because it was just for visualization. Yeah, no, that's a great point. Thanks, George. And also, again, it's good that I came up here to show you, because then I can again make the point of our markdown strengths, right? We can see all the plots consecutively as if we were writing a report, for example, as compared to running code, seeing a plot on the right here, but then the next plot you make oversees that previous one. So this is why one of the reasons why I like our markdown. Okay, so the next thing here is I want to show you just a relationship that I think is kind of interesting to look at. So if we do ggplot call again, and then we say yield 17 as our data set, and then on the AES function, we say x equals dry underscore yield, hit enter just for visualization purposes, y equals speed with S uppercase. And then you go at the end of that last parentheses, add a plus, hit enter, and type geom point. So this is basically going to create a scatter plot where we have dry yield on X, speed on Y. You know what? Actually, I just remember now. Let's flip them. Instead of having X dry yield, Y speed, let's do the opposite. So to do that, you can just come here and change, like, instead of X, you call Y, instead of Y, you call X. So Y equals dry yield, X equals to speed. I think that's going to be easier for us to relate to.
The order doesn't matter there, right? It doesn't, it just knows.
It doesn't matter because we're calling the arguments Y and X.
Yeah.
If we were just saying dry yield and speed, it would put the first one as X, the second one as Y. Yeah. So, we can see here that these very high yield points were created on these very low speeds. So that's another way for us to really understand that, the speed itself is not wrong. It's just that under low speeds, we possibly end up with erroneous yield data. So just to add that component. And because this is a scatter plot, I want to show you a quick trick that I really enjoy here on ggplot. So after that geom point, you add a plus, hit enter, and type geom_smooth. So this is going to add a trend line to your data. That is a spline. It's basically a wiggly regression line that tries to fit your data in a wiggly way. So it's not like just like a straight line going down or up, like a linear regression with intercept and slope. It's just wiggly. And it's really helpful just to sometimes you have a cloud of data, you don't really, it's hard for your eyes to really see the pattern. And if you just add a smooth there, you can see that pattern, that really high yields under low speeds, probably all the way up until, I don't know, 1.5, 2 miles per hour. And then it kind of stabilizes more.
Professor, can I ask a question?
Yes, absolutely.
What does the shade behind the line represent?
Yeah, so that is a standard error pretty much. And if you want to know more like how that's calculated, you can just do like, if you do help geom smooth, you can read the documentation. It's going to give you a more detailed explanation of how it calculates that. But yeah, so I'm not going to go through that now, but I just want to let you know that you can just go through that and understand how that was calculated. Okay, so I want to ask your input here. So I think we can all agree that we have to clean this data, right? We cannot just use as it is and start doing, I don't know, zones or recommendations based on a 10,000 pounds per acre data point, for example. And that's not the only one that's a mistake. There's actually going to be a lot more that we're going to see here. But I think it's pretty clear at this point that we need to clean this data before we actually work on it for creating some type of recommendation. So from a yield map quality perspective, and based on what we've seen here, what do you guys think we should do? Like, what should we filter, and perhaps how? Like, should we keep certain high levels of a column or low levels of a column, or what do you think?
Maybe using a box plot to find the outliers.
So that's a good it's a good approach as well. I personally prefer densities rather than box plots. I can send you a post explaining why. That's going to be very informative. But here we can kind of see that we have those outliers on this geom density, right? So what would you say that we would need to do here if we look at this plot? You guys think that perhaps we should remove these high yielding points here? They're probably not true. I think that would be a start. What do you think we should do with speed? And especially if we look at this plot here. Oops. Here. I mean, very, very high yields at these lower speeds. Maybe should we try to remove data points that have a very low speed? Right? Can you say that again, George?
It sounds like a good plan.
Yeah. I think at least those, I think, gives us some indication of how we would approach cleaning this. So I would just say here.
Yeah, let me mention one thing too about other issues with speed. So the data point that we removed, remember it was on the left side of the field, on the west edge of the field that we removed. Yeah, that data spot there. You know, if you look at the geography of the field, and you never want to do this without physically knowing the field, right? I mean, if somebody sends you a data file and you start cleaning data, you don't know the field, big mistake. you should say no, thank you. But my guess is, I wasn't there when they were harvesting the field. My guess is they drove the picker here, they were harvesting, and the guy stopped, who was driving the machine. His name is Russ. And so Russ stopped, and he forgot to, in the yield monitor, there's a switch that when the header is down and you're in harvest mode, it's collecting data. When you bring the header up, the switch turns off and it tells your yield monitor stop collecting data. So typically when they stop, they bring up the header. And if you're yield monitoring, if you're collecting yield data, you have to remember to do that. So we have lots of instances in the yield data we may be looking at where this happens. So he stopped, the machine was still feeding cotton in and, assigned a super high yield to it. So lots of things that you have to understand about the yield data before you start looking at cleaning. Another thing I want to point out, Lou, if you could go to that streak, the low streak at the very southwest of the field, like right at the edge, right there, yeah. So who can tell me why there's a solid streak of very low yield there? What can you guess happened? Think about the width of the machine.
Because half of the combine was outside the field.
Exactly. So there were probably, so this was a 6-row machine. There was probably 4 rows or 2 rows left for some reason. And so they ran down there. They didn't change the spacing of the header in the yield monitor, and you got this artificial streak. So what I'm trying to emphasize here is it really pays to be involved in the yield monitoring or have some perspective of what goes on in the field to be able to interpret these data, right? Because you could just as easily, if you don't know that, say, oh, okay, they probably forgot to plant as much seed there, or they missed a couple of rows in planting. Okay, you still get rid of the data, but it's good to be able to interpret those things.
That was really, really great explanation. And we're actually gonna, that is one of the reasons why we will apply one of the filters when we're doing the yield data cleaning that you guys will see coming up. And that's a great point.
We don't want to go into these filtering mechanisms blindly. We want to understand why we're doing every one of them, because they're all related to the way the machine was harvesting one way or the other, and the errors that causes the yield monitor, because the yield monitor is not a super smart machine. It just knows what's coming by, right? And it just tags it with GPS data, so it causes problems. Okay, let's go.
What about the high speed? Dr. Velides earlier mentioned that when it accelerates, then again we have low yields. We're going to do this on both ends.
Yeah, so when we actually get to the yield monitor data cleaning part of the script, you're going to see how the way that speed is incorporated into the analysis. But yeah, it's going to basically trim both the low and the high ends, but not just but it does that using a objective way. It's not just it's not like we are looking at here and saying, well, I think maybe here and maybe there, it's not subjective. It is something objective using statistical principles to do that we're going to see when we get to that point. So class today goes till 10, right? So what I want to do here is just quickly tell you, so from a yield map data quality perspective, we're going to be filtering things based on the yield and on the speed, and we'll see how that's going to work when we get to those points. And now taking a step back and kind of for a moment forgetting that this is a spatial data set. If you think just about if this were just a regular data set, could be like your experiment data set that is a lot simpler than this. There are some steps that every data set goes through that we call data wrangling. And data wrangling is, again, not related to specifically yield data. It's any type of data. Any data has to go through some data wrangling steps. That some of the ones that I thought that this data set could use, I just want to tell you them now, and we're going to implement them next class, is, for example, standardize the column naming style. We see that, like, they're all some of them are completely low uppercase, some just the first letter. And this is actually a pretty consistent pattern in this data set, but some data sets are just complete mess. And especially if you have special characters, as you guys have seen, we're using the column names for plotting functions, for filtering functions, even for analysis functions. So you do not want your column names in R to be too long, too complex, have special characters. All that is just not a good idea. So we're going to clean those names first. I'm only going to select the columns that we're going to use to make this simpler. So as we talk about speed, dry yield, X and Y are the ones we're going to really need moving forward. So we're going to select only those. I personally really like having my columns to include units, so I know what they mean. Especially, I mean, if I'm in Brazil, I know it's going to be kilograms, going to be tons, and even then, sometimes you don't know if it's kilograms, megagrams, whatever it is. And if you don't have context, you may not be able to guess. But here in the US, it could be English, it could be SI. I think it's really useful to have the measurements followed by the unit that they were measured in the name of the column, just so it's very clear. Also, we're going to create some of these, transform some of these columns here to the SI unit system. Have yield in kilograms per hectare, speed in kilometers per hour. And then we're finally going to transform this into actual spatial objects that R sees as such. As of now, R thinks is a regular data frame. It doesn't know that is a geospatial object. We're going to do that. And then when we come to do that, we're going to have to assign a projection and also change that projection to a different one. If you guys are not familiar with that, I'm going to be sending an email today with a quick chapter, like it's a very short chapter that explains some of these differences that you don't have to go through if you don't want. It's not going to be an assignment in itself, but it's probably going to be useful if you're not familiar with these topics. Okay, so we're going to do all that next class. And before we depart, I just also want to quickly show you something right here, if you have not seen it. So on my blog, so if you go on teaching, you go on the blog, you go on the overview, on the agenda, I'm adding links to YouTube videos of each one of the classes if you guys want to watch that. What I'm trying to do is for each one of these videos here, I'm trying to add timestamps. If you don't know what that is, it's basically just like breaking down this video into chapters, and they're all shown in the description. So show in the description what topic it is, what timestamp that started, and then you can also browse those chapters directly on the video. So you guys don't have to watch an entire 1 hour long video that you're just looking for one small detail that we spoke in class. So just wanted to make that clear and remind you as well that we do have a reading assignment that's due next Monday. It is the paper that I got, all the mathematical functions that we'll be applying to clean this data, I got from that paper, and that paper really explains the main sources of error for yield data, how it works, and why we have to do them. So that is an assignment. You will have to read it, and you will have to send me your answers to some of the questions that I had there. I just want to show you quickly here. If you feel comfortable, you can, so assignment 1, you can just open this .md file. MD is a markdown file. It's gonna open somewhere in RStudio. For me, it just open a different RStudio window, but it's just some questions here. If you want, you can just come here, add your answers, save it, and then you can go to the folder where you have this file and just add your initials at the end of the file and send me this MD. If you prefer to use Word, that's also all right. You're just gonna have to copy and paste this in Word, but feel free to use markdown files and share that with me that way as well. Okay, Sorry, I know we're a little bit going above
But you would
time.
like everybody to send these to you by email? Is that right?
Yes, yes, and I have that information lower here on the assignment as well. So you can just send to my email by Monday, 11:59 p.m. Okay, does anyone have any questions about what we did today, or maybe about the assignment?
Just in case we don't have any, since we're sending assignments in by email, please copy me on the email you send Dr. Bastos, just to make sure that at least one of us gets it. And then please ask for confirmation in your email that the assignment has been received, okay?
And I will also keep that in mind, and I'll send you an email saying that I got it.
Yes. Generally, in the past, to avoid these kinds of things, we've used ELC to add assignments so that, the timestamps are there. But since we're just so few of us in this class, I think it's fine to go back and forth with email, and then makes it a little simpler for everybody.
Perfect. Sounds great.
Great, thank you. I think
Yeah.
this was really interesting today. I enjoyed learning about how to do this. Actually, step by step instead of using the black box approach.
Absolutely. And it's I think, up until now, we really just explored the data to understand some of the potential issues. But when we actually start doing the filters, I think it's going to be even more exciting just to really understand, how these black boxes work. If you were
So there is a piece of software called Yield Editor that paper references and the paper describes that software. But once you use it, you don't really know what's going on. You can just use it blindly.
Absolutely.
All right, great.